Let us look at the arithmetic progression. Sometimes it's also called an arithmetic sequence. Alright? Now, basically, when you have a sequence and the terms, each term is generated from adding a constant number to the previous term, then what you have is an arithmetic progression. Alright? So, you add a constant to the previous term. An example. You might start a term with 1. Now, that first term generally is referred to as A. Now, in this case, A, let me rewrite that, kind of look like D. A is the first term. Now, you add a constant, 1, 2, 3, 4, 5, and so on. The constant being added here is, what would it be? Is 1. That's 1. Let me write with smaller points. 1 plus 1 is equal to 2. That's the following term. Now the term following 2, you must take 2 and add 1 to 2 to get that term. The term that follows 3, you must take the 3 and add 1 to it to get that term, 4. The term that follows 4, you take the 4, add 1 to it to get 5. Alright. So, the constant is equal to 1 in this case. Let's look at another sequence. Suppose you have 1, 3, 5, 7, and so on and so forth. You start with 1. 1 plus, what do you add to 1 to get 3? 2. You get 3. 3 plus 2, you get 5. 5 plus 2, you get 7. So in this case, our constant is 2. Alright. Suppose you have another situation. You start with 4. And you get 1. Then you get -2. Then you get -5, -8, and so on. Interesting. You want to know what the constant is. Now, one quick way of finding the constant is to take any term and subtract the previous term from it. Alright? So, you take -5 minus -2. This is the same as -5 plus 2, which is what? -3. It seems as if our constant is -3. Let us test it and see. 4 plus -3 should give you 1, right? This is the same as 4 minus 3 equal 1. Okay, it works so far, we get our 1. 1 plus -3 is 1 minus 3 is -2. Okay, seems to be working. -2 plus -3 is negative 2 minus 3, which is negative 5. Negative 5 plus negative 3 is same as negative 5 minus 3, which is negative 8. Alright. So there we have our constant. Now, what we did a while ago was we took the term and subtract the previous term from it. Would it work here? Let's see. If we take 3 minus 1, we get 2. Alright. 5 minus 3 is same 2. 7 minus 5 is what? It's 2. Oh. Seems to be working. Let's try it with this. We take a term and subtract the previous term. Subtract the term before it. Let's see if it works here. We have first term is 1, second term is 2. 2 minus 1 is 1. 2 minus 1 is 1. Alright. The third term was 3. Let's subtract the second term from it. 3 minus 2 is 1. The fourth term, 4, minus the third term, which is 3, is 1. Alright. Fifth term is 5, minus the fourth term is 4, is 1. Oh, so we keep getting 1. Oh, so here now, what you do to find the constant that you keep adding, you can take any term minus the previous term, right? Subtract the previous term from it, and you get that. Now, due to the fact that you can do that, you call it the difference between a term and its previous term. Generally, instead of using C for constant, you use D to show difference. And due to the fact that that difference is common throughout all the terms, you call it a common difference. So D is the common difference. So that's our common difference. All right. Nice. Now, let's look at the terms of the arithmetic progression. Let's erase these. We're going to look at them in a more general way. You start with the first term, A, comma. The second term would have to be A plus our constant difference, or common difference, D. The third term would be what? It would be this second term, A plus D, and then you add D to it. Alright. The next term would be the previous term, A plus D plus D. So it's A plus D plus D plus D. Then that is our next term, because we had A plus D plus D. So it's A plus D plus D, and then this other D, we add it to get the next term. Alright? Our next term is our previous term, A plus D plus D plus D. And then this is it. This and this is the same term, but to get this term, we add D now. So we keep adding that number to the previous number. It's just like you start with 5. A is 5. The first term is 5. The difference is 2. 5 plus 2 is 7. 7 plus 2. Remember, 7 is 5 plus 2 gives you 7. The next term will be 5 plus 2 plus 2. Same as 7 plus 2, which is 9. right? Now, 9 is this term. 7 was 5 plus 2. The next term would be 5 plus 2 plus 2, which we had before, plus 2. So it's same as 9 plus 2, which is 11. And so on and so forth. So we keep adding the 2. 2 plus 2 plus 2 plus 2 and so on. In this case, we don't have a number, we lose letter. So it's d plus d plus d plus d and so on. Alright? So here, this is an arithmetic sequence. Arithmetic means you add a number, you add that common difference, that term, you keep adding that constant, which we call d, common difference. Now, here, let's get back to this. Let's put these in a simpler form. You have a, then you have a plus d, then you have a plus d plus d is what? 2d, so it's 2d. Alright. You have a plus, this would be 3d. Then you have a plus, let me rewrite that a plus, this would be 4d. Alright. The next term would be what? What do you think it would be? Is a plus 5d, it would be. And so on. So it goes on and on. Now, here. This is our term number 1, first term. Second term. Third term. Fourth term. Fifth term. Sixth term. Alright. Now, how will you write the 100th term? Well, the 100th term would be what? It would be a plus, because that's common throughout. It's a plus. Plus what? What do you think? Notice for our 6th term it is 5d. Our 4th term it is, our 5th term it is 4d. So it seems as if throughout here it is a plus 1 less than the position d. So it's 99d. It would be. Alright, let's go back to this now. This thing is a plus. The 6th term is 5d, which is 6 minus 1, d. You see that? So it's a plus 6 minus 1, d. Because it's a plus 5d. Right? So in this case, you had a 6th term, term number 6. You minus 1, d. Pay careful attention now, you know. What was the term before that? It would be a plus. No. It was the 5th term. So you include 5, but 5 minus 1 d. Because 5 minus 1 is 4. You see that? In this case, we have a plus 3d. But it is term number 4, the 4th term. But instead of 4 something, we have 3d. So it's 4 minus 1, d. In this case, it's a plus. The 3rd term does not contain 3. It contains 2. And it says 2d. So it's 3 minus 1, d. we want to form a pattern here. Term number 2 is a plus 1d. D means 1d. So it's 2 minus 1d. What about the first term? It is a plus, well, 0d. Because there's no d there, it's 0. It's really 1 minus 1d. Alright? Now, here, how would you write this generally? Without numbers, or just an nth term. So the nth term would be what? Throughout you have a plus. Alright, we want the nth term. Now for the nth term, look at this. This first term, 1 minus 1d. Second term, 2 minus 1d. Right? Or the term number 2. The nth term, 2 minus 1d. The third term, 3 minus 1d. The fourth term, 4 minus 1d. The fifth term, 5 minus 1d. The sixth term, 6 minus 1d. So the nth term would be n minus 1d. So the nth term of an arithmetic progression is a plus n minus 1d. Alright? So term number n is a plus n minus 1d. Let's write it down here. So term number n, the nth term is a plus n minus 1d, where a is the first term and d the common difference. Alright. In our next video, we'll look at the sum of an AP.